the principal investigator of the e-Yantra project. I'm a professor at the Computer Science Department of IIT Bombay. And e-Yantra is a project which we've been running for the last 10 years. It's funded by the Ministry of Education, and it had its humble beginnings in training students from colleges other than IIT over the distance education program in engineering skills, in embedded systems, robotics, and things like that. Over the years, we've been training students through a competition in which we train students while we make them compete. So we are unlike other competitions in the sense that we train you. So it's like a massive MOOC, a massive online course, open course. So over the last 10 years, we've been pushing the boundaries of how and what we can train young students in, engineering students. And we are amazed every year at the higher and higher levels of capability that we are witnessing in the engineering college students and as to what we can do with them. We've been training in complex skills, like for instance, we have a mobile robot in a greenhouse here at IIT Bombay, and we have an agricultural kind of setup. So we've trained students to program this mobile robot, a full-size robot, to harvest tomatoes in a greenhouse inside a simulator first. And then once they've mastered that, we take a small number of students and let them actually program the mobile robot in IIT Bombay inside a greenhouse remotely, just like you would program a Mars rover. And that robot goes around plucking tomatoes in a greenhouse in IIT Bombay, but programmed by students across the country. That's the kind of level to which we've been able to train students through a competition mode which lasts over 6 months. Naturally, it's a challenge over 6 months. It's not easy, but students have found that they've learned a hell of a lot in the process. So we have two competitions now. One is a robotics competition in which we train you, which has begun this year. And we have an innovation, a challenge, which trains you how to do startups by using these engineering skills. Now, what we find increasingly that e-Yantra has become, it's become that important engineering project-based learning experience, that practical experience, which students really lack in our higher education system. We have a country in which the economy is growing at an exponential scale. We need lots and lots of people to build new products and services which will come through startups. And half the population of the country is below the age of 25. That means almost 700 million people. But unfortunately, they don't know how to solve real problems. They can solve, exam type of things which are not very useful. They don't know how to solve real problems, which means how to take a problem outside there, solve it, and turn it into a product. So in the journey of a solution to a real problem in society, it starts with a prototype and then you turn it into a product which actually works out there, right? Not just it works once first time and then after that it doesn't work. So we have a fair amount of experience of this on the project. And today we have a talented young member of our team, Arjun Sadananda, who has been doing a lot of work in robotics with us. He is a mechanical engineer originally from NIT Surathkal, and he's come to us through e-Yantra competitions. He's part of the team here, and he's also registered to do a MTech in control systems at IIT Bombay. So it gives me great pleasure to have here with us Arjun, who will take you through a product development life cycle presentation, talking to you about product development and sensitizing you to that whole topic. So over to Arjun.
Thank you, sir. Thank you so much. Yeah. So, okay. So I guess I'll start. Before I start, I think first thing I'll do is try to get to know the audience so I can try to I may not change the presentation too much. It's going to be the same presentation whether you're a professor or a student, but still, just to know who the audience is, can I get a quick raise of hands if you're a BTech student? Uh, you can, there should be a raise of hand option somewhere there, reactions or raise of hand, anything should work. If you're a student of BTech first year, fourth year, any of the whichever year you're in, if you're a student of BTech, you could raise your hands. Oh, that is a surprisingly small number of hand raises. I'm not sure what else should I be expecting today in the audience. Okay, if you're in the teaching profession, maybe someone in as a professor or a teacher or any of the teaching professions, basically, or yeah. First, lower all your hands. I mean, so it doesn't get mixed up now. All the BTech students can lower your hands, and uh, anyone from the teaching profession? Okay, so I guess we have a few hand raises there as well. Okay, so we have almost the same number of teachers here as the number of students of BTech, surprisingly. But okay, cool. And what else do we have? There's a lot more participants, I think. BTech we have covered, teachers we have covered. Maybe uh, what else is there? Okay, students of any domain, not necessarily technology, not necessarily BTech, students in general. Students over here, please raise your hands. Huh. I guess this also kind of indicates to me how many of you are active listeners over here. I would expect the start of the talk, at least people would be actively listening. So if you are listening to this, maybe raise your hands. So I know if you have at least if you're just here for the attendance or are you actually listening? If you're listening to this, raise your hands. Just that should basically mean everyone raise your hands. Okay, just engagement test basically. Okay, I guess not. Okay, where's the hand raise count? I'm trying to find the hand raise count, but I can't see it yet. Hmm. But yeah, roughly it looks like less than half of the people are. Okay, no, actually half of the people are at least listening. That's good. Cool. Okay, so I think I should not delay anymore. I should start soon. Okay, we have an MCA student, not BTech, so that's good. Okay, so oh yes, I've left out one particular domain. Everyone lower your hands and professionals probably working already somewhere. Maybe only those guys can leave your hands up. uh, already working in some company or startup or basically in the working, you would classify yourself as working, earning income maybe is a way to say it. Okay, so we have a few of working professionals as well. Cool. So I think that's one third, one third, one third. It looks like at least based on the hand raises. Okay, great. So I think I'll start then, now that I know who's in the audience. This is going to be a relatively short talk, I think. I just have one simple concept to be presented, which was introduced to me back in my BTech days. So you'll see that I used to use WPS that time. So I'll share my WPS presentation. I've just changed it a bit to make it more suitable for this event. So yeah, product development process flow. Am I clearly audible? I think it should be, now that I've seen enough hand raises and responses. What about the screen? Screen is clearly visible, all good, no issues. You can say it in the chat maybe if it's all okay. Mm, Yes, okay, great. So I'll just open chat up here. Okay, cool. So I think we are all set. We should start now. Let me just go back to the first slide. Okay, yeah, it starts quite abruptly, starting straight away with the objective. What is the agenda today in the next less than an hour? I should not take too long, maybe even half an hour. So, what is the agenda? What is this product development process flow? So that is the first thing. What is product development process flow? That I guess I'll do first. And then in the context of BTech projects is what I'm actually focusing on. So the first time I was introduced this topic, it was in a course. It was during my BTech, as I said, in industrial. I forgot the title of the thing, but it was in the context of in industries, what is the process followed while you have to design a new product. It was part of two courses, in fact. One was the basic version, one was the advanced version, but this process was introduced there. And what I have done is kind of simplify the process, I guess, for BTech projects. Because I think the first time I used it was in one of the robotics competitions. You might have heard of Robocon. So that back during my BTech days, I had taken part in Robocon as well. So during those days, I had used it first time, and since then, I've fallen in love with this process. I've used it in every project since then, basically. It's a very effective process, and that is the reason I'm sharing it with you all. Every team who has worked with me knows about this process and used it thoroughly. So yeah, I think today I'll be sharing it with all of you guys, and first time I'm making a bigger presentation of this. So yeah, in the context of BTech projects, how do you implement this product development process flow that is usually used in the industries for actually making all these products that you use every day, right? But then this is not just limited to kind of BTech projects, although I've used BTech projects because that is where I used it. But this process is, I found it kind of useful even in personal life in some sense. The lessons that you learn from this process flow is kind of useful even in your personal life. You'll have to see how that happens, but it's useful in most unexpected places. So uh, just a second, what do I see on screen? Okay. Huh. So yeah, all kinds of disciplines, not necessarily BTech projects. I'll show you one example soon. But yeah, just a side note. And in fact, I think you have already used the process to a certain extent. You might have, it's not going to be something very revolutionary. Oh, what is this new thing I've heard today? But what will happen is you'll get a clear idea of what the process is. So when you're actually doing the project, you'll be more conscious about the process rather than simply doing it without any plan, right? And also, when you know what the process is, you'll focus on what you should be doing at that stage of the project. What I've noticed is usually I'll be talking about two steps in the process. In most projects that I've actually mentored in eYantra through EY and EY people tend to mix up these two things. And when you mix up these two things, you kind of lose out on certain better products that you could have designed, right? So that's the reason knowing the process is useful. So you can distinguish between, for example, these two steps that should not be combined, but is always combined in practice. So we'll get to that soon. So that's the idea. Let's talk about, I mean, this is, I guess, in one slide, the entire presentation. Today's 40 minutes is going to be about this one flowchart. And probably one of the more important parts of this step that I've been talking about is concept development. And that I'll have one extra flowchart inside concept development, and that is it. This is the entire presentation for the day, right? So, but before we get to that, I think I'll quickly also mention planning is something that was probably covered in the last technical session, if you were there. It is the part where you decide what problem to even solve, right? That is even bigger question. What is the problem you want to solve, right? That's not something trivial, you know. Usually in robotics competitions, you are given a problem to solve. So you don't have to do the planning phase because that the output of the planning phase is given to you. You're already given the problem to be solved. So we are more concerned with the rest of the process flow. But planning is something that was probably covered in the last technical session, right? Anyway, before we get on to the actual process flow and show you the entire thing, you might want some more motivation on why we want to do this, and also a little bit of validation on why I should be talking about this, I guess. So I'll do some show of business now. I'll show you some of my projects that I've done where I've used this process flow. So that'll probably motivate you to even consider using this process flow. Otherwise, it's just preaching without practicing, right? So I'll just show you some of the projects. This was EYRC 2016. This was probably before I learned about product development process flow. So I might have done a bit of over engineering here in some designs, but so this is one of the ARM design is what I'm referring to. We are given the problem of you have two servos. How do you pick up objects? That is itself a very simple product development challenge, right? There are multiple designs that you could come up with. This is one of the designs that I decided to go with, where there's laser cutting involved, two-dimensional sketches, and you fold the laser cut parts and you make it a three-dimensional assembly. So this is one product where I had not necessarily known what product development process is, but I'd probably implemented it in some way. There might be some better solutions that might be out there, but I'm not aware of it because I did not follow this process. We'll get to why that is. EY SIP 2017, this is another product. You're asked to design a robotic arm that can pick up objects. So here, I should say there's one step in the process flow where it's called detailed design. That is where I had some lacking, but I kind of implemented the first part of the process flow quite thoroughly, which is to decide what kind of a design do you want, like 6 degrees of freedom, how many degrees of freedom, what kind of assembly of motors. There are quite a few different designs for robotic arms, right? So this is one design that was finally chosen. And then this is a project since when I have actually thoroughly used the process. But actually, I should actually correct myself there. Not this one, the next one. This design, we had used the process flow, but this design we had not. So just a second. Oh, I think you guys are not able to see the slideshow. Ah, you should be seeing just the window, I'm guessing. One second, I'll just share. I was in presentation mode, but I think you have been seeing just the window. So maybe now if I share, either I should do share screen, but if I do share screen, I think you'll see black boxes. Now you should be seeing the presentation. Could someone confirm in the chat if you see the two
Yes,
robots?
yes. Now we are able to see a presentation mode.
Ah, okay. There's quite a few slides that were missed then. Okay, cool. So maybe somewhere in the okay, I see a thumbs up. So I think the participants are also on board. So yeah, I was saying. Yeah, this part was anyway just text, so there's not much. This was a flow chart I was referring to that we'll be focusing on throughout the um, 40 minutes that we have, that I'll be presenting rather. And the planning phase is what we had talked about, and motivation is what we are doing right now. So this is the first robotic arm that I mentioned, the 2D sketches, laser cutting, and that kind of product. Then this was a robotic arm that had 6 degrees of freedom, where uh, I was talking about how detailed design is the part where I kind of missed out on some points. But and then this was the part where I was before I was told that the presentation was not visible. So this robot, there is one particular design decision taken here about how to lift this rack. Uh, Maybe I'll come back to this slide once I've introduced to you the entire flowchart so I can be more specific about what I'm talking about. So this was before I had started implementing the process flow. And the result of that, not using the process flow, is kind of visible in one major design blunder that we had done. Not exactly a blunder, but it is still, I would consider it a blunder. It was functional, that is not the problem, but it was not optimal. It was not the best solution that we could have come up with. It was working for sure, but it was not the best. My frame seems to be frozen. I'm hoping you guys are seeing and hearing everything. Okay, you can put it in the chat if you feel anything is wrong, but yeah, I think I'll continue. Okay, so yeah, where was I? I was telling about that. What I'm saying is this robot on the left specifically was not the best robot that we could have designed. If we had done the process flow more thoroughly, then there could have been a better design for this. And I'll be specific when I come back to this slide after discussing the process flow. So then we started implementing this process and in this particular design. And yeah, all the decisions taken here was after going through that process. So yeah, this was the next two robots, and then we went on to, why is my screen all jittery? Mm, I think I'll stop sharing. I think, are you guys seeing the screen clearly? Can someone confirm in the chat or by voice? Okay, 11:27. Yes, okay. That was the older message. I'm not sure, but I'll share again. Okay. And this time I'll share the entire screen. So you might see some black patches, but at least the presentation will be smooth, I think. Okay. Was it clear the entire time? Okay. For some reason, my screen was all jittery and it was not so smooth. So I'm just starting that again. Okay. Hopefully it should be clear now. Okay. So, and then this was a petrol fish theme that happened in EYRC. This particular fish was designed, and here probably the involvement of the process flow was a little lesser, but still I wanted to show you the design, so I'm showing it anyway. So yeah. And then EYSIP, this was when I started mentoring a project, and again here, if you speak to the interns that worked on this project, they would tell you how the process flow was used and how effective it was. So yeah, this was the UAV project. Oh, sorry, not UAV, the underwater vehicle project, not the flying vehicle. So this is a platform design, that e-Yantra platform design, where we have a UR5 robot and then the uh, ground vehicle at the bottom, and we had to fuse these two. So the trolley design was a design that we came up with, and this also had a bit of the process flow in it, but not so clearly. It was a very quickly implemented project. So yeah. And again, in the internship next year, we implemented this process flow for the battery swapper and arrestor project that was there in EYSIP 2021. So clearly, okay, yeah, I did mention that although I'll be speaking a lot about BTech projects and robotics, maybe, but this idea has been implemented in something completely different, which is basically the question of how do I teach Python to school kids? This was the question. How do you teach Python to school kids? That doesn't seem like a product design problem, right? But clearly, what you're doing is designing a product that will help you teach Python to school kids, right? So in the Yantra school robotics competition as well, just to design the theme itself, we use this process flow of what challenges do you do, what tasks do you design, and all of these questions were answered by following this process flow. So yeah, something very disconnected from BTech projects, but something where you could very thoroughly use this process flow. So just a second. Okay, sorry about that. Quite a few interruptions already. Okay, finally, we are on the topic of product development process flow. So this is the process that we have been using all this time. So let's talk about what is this process I've been telling. So clearly, these are the steps. I've kind of classified that into planning, concept development, and all these three steps that you see after concept development, where system level design, detailed design, testing, and refinement has been merged into one thing. Because I guess in BTech level projects, you wouldn't want to classify so much into these further three sub steps that happen in industries probably. But I would just combine that all of those three steps into one step. So we'll talk about those three steps as one. And production ramp up is basically just the final product development, right? So actually building the final product. So yeah, let's talk about the planning phase. I've actually already told you about what the planning phase is. This is the objective or the rule book or the arena that you're given in EYRC or yeah, I guess usually in robotics competitions, this part is already done by the organizers. The organizers will give you a problem statement in hand. And that is basically the planning phase. You know what the problem is. But in EYIC, for example, when you take part in ideas or innovation challenge, you would have to figure out this part as well. The planning phase is something that you are responsible for. You have to decide what the problem is that you want to solve and how will you solve it. What is the solution? That is what we'll discuss today. But what is the problem you want to solve? That we'll not discuss today. That is a different. That is as I mentioned, I had taken two courses, right, for this entire product development process. The first course, I think, was heavily focused on the planning phase only. The second course is when I kind of introduced like I got introduced to these other steps. But yeah, the planning phase is quite a important step, but that's a whole separate presentation by itself. So, I think that was what was done last time. So I'll leave that aside, and we'll jump straight to the second step, which is once you know what the problem statement is, how do you solve it? What is the solution that you want to come up with? So concept development is the first step, right? And I think you would have done concept development. But I want to further break this concept development into two stages, and this is the stage I was talking about. A clear distinction between concept generation and concept selection. What we do in practice, if I had not told you about all of this, is probably you will do concept development directly. You'll not do the separation between concept generation and selection. You'll just do development altogether. But you will do it. You will have to generate a concept, right, before you design the solution. Uh, but you will not do it by separating generation and selection. And I think that is a very important step. And that is not intuitively happening in most projects. So let's talk about what the generation process is. I think by name itself, you can create the distinction. You could put it in the chat, I guess. Or if someone wants to talk, you could put it in the chat and we'll unmute you or something like that. So um, by the word itself, does it make sense what concept generation and selection is? You could just say yes or no also. Make sense maybe if you understand just by the name what that is. Yes, I see a yes. I see one thumbs up. Yes. So I think quite intuitive, right? You can already guess what I'm going to say in the next few slides. So concept generation is generating concepts, and to generate concepts, you'll have to search obviously in two ways. You can search externally, look at what other engineers have done, look at what other people who have tackled this problem. There are surely many other people in this planet who have tackle the same problem that you're tackling. If it is a completely new problem, and I think this is something that might have been spoken about last time, that if it's something completely different that no one has touched upon, either the problem itself might be unnecessary, like it may not need a solution, which is the planning phase fault, that you have come up with a problem that need not be solved, and therefore no one has tried solving it, or it is a problem that actually is like $1 million problem probably. Like it's a very it's a jackpot that you have hit basically. You have found a useful problem that no one has solved. You probably have a startup idea that that is surely going to succeed. I would assume so. uh, Either way, there is going to be external solutions in most of the problems that you come up with, right? Or that you're tackling. So searching externally is one major chunk of searching concept generation. And the other obvious option left for concept generation is internal search, where you and your team sit together and discuss, brainstorm, and come up with a bunch of ideas that you can come up with to solve this problem. So you'll create a huge list of problems. So this is actually what is also called a diverging step, because you're going to diverge. The funnel, actually there is a, oh, I've forgotten to add the picture over here. But if you look at the picture, it starts like you have the problem, it diverges and then converges in the next step. So what is a diverging? You create a big list of solutions to this problem. And here's the key point. When you're generating, you shouldn't be critical about how practical it is, will it cost too much? All those questions about is this solution good or bad? Those questions should not come up now. Whether it's good, whether it's bad, whether it's pointless, you should just add it in your list. So that is an important point. If you have to take away one point from this session, make sure to take away this point, that you don't be critical when you generate concepts. You just generate concepts freely, like without any constraints in your mind. And the presentation has stopped for some reason. Oh, Ashraf has gotten presentation right somehow. How did that happen? Wow. Okay. I guess I'll share my screen again and I should get it back. Okay. And we are back, hopefully. So yeah, searching externally and searching internally. You have generated a huge list of concepts, and okay, just to clarify the problem again, that is kind of obvious. What you're supposed to do is understand the problem itself properly before you try solving it. That's clearly the first step. Understand the problem, clarify the problem, and then you search externally and search internally. I'll skip these two slides. Yeah, so searching internally, you need a blackboard. Searching externally, you go for papers and you look at videos and you search all over the internet, basically. Search, and not necessarily the internet. You could just walk around and look for ideas as well that people have. Like this problem, if it is a real life problem, you'll find it in real life as well, right? So searching externally and searching internally is obviously with a blackboard. And now comes the concept selection phase. So here's the picture that I was talking about, diverging and converging. So diverging is when you have created a bigger list of ideas than necessary. And then selection is when you start canceling out things. And how do you cancel out things? That this idea is not good, this idea is good. How do you decide? So for that, there is something called concept scoring. And this is, again, if you have to take away one other point from this entire thing, this is the slide that you have to take away. So concept generation principle is one point that you have to take away. Second point that you have to take away is how to do concept scoring. This is a very objective way of doing things. So if you want to take a screenshot or whatever, you can take this as an example. How do you do concept scoring? You have to have a list of parameters. So on the top, you can see is a list of ideas that you have come up with. This is the entire list of concepts. So basically, when you diverged, you found a set of concepts, solution concepts, right? So that is one of the axes over here in the table. And the other axis is parameters. What matters to you is what you are writing here. Does cost matter to you? Does the time of production matter to you? Does the availability of materials matter? The size, the power, and all of those other technical parameters, do those matter? And how do you explicitly say what matters? That is defined by the weights. So you have the list of parameters that these things matter, and how much does it matter is defined by the weights. So if you want the cost to be extremely low and that matters a lot to you, then cost weightage will be high, which is probably the case here. You can see that the cost has a higher weight. Uh, the highest weight in the set. So control and complexity and cost are given high weightage. And if you're designing some solution to, you have to, that is again something that, okay, this is another important point. So the weightage, how do you define this? Is either you use your own power to decide that I know that this is the correct weightage, which is okay for now, which is what I have done in my BTech projects at least. But the real way of doing it in the industries, for example, is by doing customer survey. Like what matters is not what matters to you, but what matters to customers. Finally, the product has to be used by customers, right? So they should tell you what matters. And that's why the weights are defined by the customer in some sense. So you have to ask the right questions, do the right survey to figure out what the weight should be. Uh, if people say that the cost should be low, then you have to make the cost low. It's not that you get to decide what the cost should be. So therefore, the weights are decided like that. But anyway, maybe in your BTech project, you don't really think about customers too much. You're the only customer. You're making one product that will be used only by you and probably the few others in the team. So you can decide the weights by yourself, I guess, in that case. So then yeah, the rest of the process is quite obvious, right? You have different concepts, you have the parameters, you start scoring them. Whatever point system that you want, you start scoring them, and then you add up the points. You multiply the weight and add up. Clearly, you will get a winner at the end. So here, 36 points goes to the shrimp mechanism, whatever that is, and therefore the winning concept is shrimp. And need not be one winner. You might want to choose two, three winners. So let's say shrimp and rocker bogie mechanisms. These two mechanisms are the winners. So I'll use these two concepts and go on with the next step. And that is what the concept scoring. So this is again important because let's say once you have done all of the work, you have designed your final product, and your professor or your friends or someone comes and asks you, why did you choose this mechanism? Why not that mechanism? Why not something else which they will come up with? Then you will have a very concrete way of saying. First of all, there's two parts to this question. If someone comes up to you and says, I have this idea, why didn't you consider this idea? Then if that is an idea that you have not considered, that is step where was the flaw there? I've only introduced to you two concepts, concept generation and concept selection. So if someone comes up to you and shows an idea, they give a news, they know the problem. People always come up with solutions, right? If you tell a problem, someone is going to come up with some solution, whether they are in your team or not. A stranger will come up to you and tell you this could have been a good solution. So if that solution was not considered by you, then where was the mistake out of these two steps? Where did you miss? Like, what is the mistake there? uh, if someone comes up to you with the solution that you have not thought of, oh, this is something new, I didn't think of this, is your reaction, then where was the mistake in the process flow? In the chat, you could put it. I'm waiting for the response in the chat, obviously. That's why I'm kind of halting here. Anyone? There's only two answers. Either it's concept selection or scoring. I've only introduced to you, or maybe planning I've introduced, but planning clearly is not the answer. So out of these two steps, where is the mistake? It's obvious what it's. You can put any of these two in the chat and I'll respond accordingly. Either you enter scoring or you enter generation. The question is, someone comes up to you and tells you, this idea I have, and you realize, oh, this idea was not considered at all. This is a new idea that I'm coming across. But you have finished your product design, it's already ready in front of you. Then where was the mistake? Exactly, Vasanti and few others have gotten it, Bhavna as well. Concept generation is where you miss the idea, right? Which means your concept generation's exploration, the diverging was not enough. Your diverging did not diverge enough. Something else was there that you did not think of. So you should diverge enough to see everything that could have possibly come up. If someone comes up and tells this other idea, you should have already thought of that. And that is what concept generation is all about. And then concept scoring is, if I ask, if someone else comes up to you or the same person comes up to you, they show, look at this idea I have. And you say, oh, yes, I've considered this idea. And I know that my idea is better than this idea for these reasons. Which step in this process helps you in deciding that? They come up with an idea, and you have a clear answer for why my idea is better than this idea. which step in the out of the two is helping you with that answer? Scoring, right? As Mohan Sai says, as everyone knows. And clearly, that is what it is. You have your idea listed here, whichever idea you have decided. So maybe at the end of the process, you have actually designed a shrimp mechanism, whatever that is. I have no clue. But once you have designed it, and then someone comes up to you and they say, "Oh, I have this chaos idea." And why didn't you make the chaos idea? Then you can clearly compare that, look at the table, find the shrimp idea, find the chaos idea that they are suggesting, and then you can say that shrimp idea is better than chaos idea for these parameters. If you change these parameters, obviously the score also will change. If your priority was something else, maybe chaos idea would have won, and chaos would have gotten a higher score. But for the particular parameters that you had chosen, that these things matter, you decided that shrimp is better. And so you have a very clear reasoning for every decision that you take. And that is the another big reason for following a process, the concept scoring process, right? So yeah, if I have to like limit the entire presentation to 2 slides, these are the 2 ideas that I want to present to you: concept generation and concept scoring. The rest of the presentation is quite obvious things, nothing new that you will discover, I think, unless I've forgotten something. Most of it is going to be quite obvious. So if I have to introduce 2 concepts to you, it's concept scoring and concept generation. I hope these 2 things are clear. All the people who have mentioned in chat, I'm quite sure you guys are clear on it. But if there's any doubts here, you can put it in the chat and we can clarify it. Else we'll move on. The rest, as I said, is quite obvious. This thing, everyone who does a BTech project has to do it. And you would have done it whether I tell you to do it or not do it. You have to design it, right? The detailed design has to be part of the process. So I call this entire 3 steps and summarize it as detailed design. That's it. And maybe if I have to make it 2, then I would say detailed design and prototyping. So every nice to see all the thumbs ups. It looks like you guys are on board with the flow. So if I have to break down the entire rest of the 3 steps, it's detailed design and prototyping. Now that you have decided that these are your concepts, in the previous slide, you have decided that your 2 winners that you will continue to develop is shrimp and broker bogey. Once you have decided that these 2 are your winning concepts, you'll get to detailed design. You'll design both of them because designing only costs time and not actual money. So before you put the actual money, you might want to do detailed design and prototyping, because when you do detailed design is when you'll start realizing the practical issues, maybe if you have missed out on anything while selecting the concept, right? So you'll do detailed design of both of these concepts that you have chosen, and then you'll even prototype both of these concepts. While prototyping, you'll realize that, oh, this is actually much harder than I thought it was. So maybe I'll go with this design. So that's why you probably choose 2. But if you're very confident, then you can even choose one concept and go ahead with that and make detailed design of that and prototype it. Prototype should work ideally if you're confident with that design. And if prototype is good, then you will do the final design. Usually there's an assembly of different mechanisms, right? So for example, I guess I can go back at this point to the slide I had said I'll go back to in this particular robot. I said there is one flaw in this robot that we would have noticed if we had done the process flow properly. So speaking of detailed design, okay. So the flaw here was concept generation. We missed one idea. We did not even think of that idea. And we went to the competition. We saw another team that had designed, wow, uh, Dubey's emoji got me stuck. I'm like surprised by the turtle emoji over there. But anyway, nice. So the mechanism to lift the rack, there is a rack that you can see over here that has 5 shuttles. The way to lift the rack over here is we used a 4-bar mechanism, 2 pneumatic actuators, and then we basically designed 4-bar decline that. We designed two 4-bar mechanisms with two pneumatic actuators to lift this rack full of 5 shuttles. And that was our concept. We went ahead with the detailed design. We prototyped, it worked, so we manufactured it. But later we realized this was such an over-engineering solution. One small little piston, first of all, this piston's length, you can see it's quite big. If you had taken like this tiny piston, like 1/4 of the size that this piston is, or even lesser, and just put it directly under the rack and just lift it up directly, instead of making this entire 4-bar mechanism that goes in and picks up the rack and all of that, you just go inside the rack and push it up. The pneumatic actuator is so freaking powerful. You don't need to do all these over engineering solutions. You just directly actuate the vertical motion that you want using the pneumatic actuator. Such a simple idea, and we design 4-bar mechanisms and whatnot to just lift the rack up. So that is a flaw in the concept generation process, that we did not consider that idea. That would have easily won if we had done concept scoring. That would have been the easy winner. But in generation, we did not consider that idea. That was the problem that I was talking about here. So yeah, once you have decided whichever design, you will go to detailed design, and this is what I refer to by detailed design. Every element of it is design. And the reason I remember this slide is because there are usually multiple parts to your project, right? There is the lifting mechanism, for example, and then there is another part of the robot that is actually responsible for mobility. Another part of the robot that is responsible for isolating a shuttle and all that stuff. So the same robot has multiple products inside it in some sense. So you might want to do this process parallelly for different parts of the robot as well, depending on how complex the project is. So that is what I was referring to when I was talking about detailed design, that we might have to do detailed design for different parts, prototype each of them. Then you'll realize while prototyping that this idea was not practical. You might want to consider the second idea, and therefore the second idea might win, and you will choose that in your final design. And that is the final step, production ramp up. So this is where this is where all your engineering that you have done in BTech or whatever will be used. This is where you have to use all the maths and physics and all the mechanic. In my case, it was mechanical and control systems and all of that. But in your case, it could be any of the domains that you are exploring. So this is where all the theory from your classroom is getting used, basically, the detailed design part. So I'll jump through all of that because we are not talking about control systems and mechanical design here. And prototyping is the next most important thing in detailed design. Like detailed design and prototyping. By the way, all of this looks like a straight line, right? Very simple. But do you think in practice it's a straight line? If not, I mean, first of all, I think the answer would be no. I'll give you the answer. The answer is no. It's not a straight line in practice. What is it if it is not a straight line? Anyone in the chat? I'm referring to this process flow, obviously, which I've repeatedly shown. Yeah, right now it's in this slide. Spiral is what I hear. Okay. This straight line is what I'm referring to. It is not a straight line, I'm telling you. It's not as simple as the straight line. There is something else that happens. There are a few more arrows that are not shown in this. Spiral. By spiral, I'm not sure what you mean. I think I can get what you're saying, but you might want to be using other words to describe it. I see a lot of spiral as the answer. Any other words to describe it? Tree structure, okay. I just want to add a few more arrows, basically. I'll leave circular, okay. Oh yeah, circular is kind of true, I guess. Rings, okay. I guess we are getting closer to the answer. Basically, what I'm trying to say is it's iterative. It's not as simple as do it once and finish. It's not a one iteration kind of a thing. It's an iterative thing. And when I say iterative, I mean it'll loop back somewhere in the point. So let's say we have done prototyping and you realize, oh, there is a problem in detailed design. You'll go back to detailed design step and you will loop back. So you'll keep looping back to whatever step. Once you have done detailed design and testing, you'll realize, oh, this concept itself has a flaw. You might even go all the way back to the concept development phase if needed, and you'll realize that out of the two concepts that you have chosen, this concept is not the real winner, the other concept is the real winner. And then you'll again go through this entire process of detailed design and prototyping. So all of these things, anywhere, there can be loops basically. There are loops all over this place. You could loop here, you could loop through the entire flow itself, and all of that happens. So that's what I mean by looping. So yeah, that's one point. And so yeah, detailed design and prototyping is where you start realizing more things. You start looping more. Most of the loops in practice will be in this phase when you come to detailed design and prototyping. So here you start defining the specs and everything. Everything becomes crystal clear, exactly what your design is. In concept development, you did not make an entire CAD model, by the way. You can make a sketch and say, this is my concept. In detailed design is when you start making CAD model, right? You start defining dimensions and motor specs and all the specs of different components that go into your robot and all of that stuff. Or in your case, whatever, like in EY SRC theme development, you could start designing exactly what each task is and all of that stuff. So this is pretty much what will go out to the audience in the end, once you have tested and refined it, basically. So yeah, and the last step is quite obvious. Once you have done all of this, now you know your design is done. Like it's solid. Like you don't need to go back and loop anymore. Most of the loops are over. Now all you need to do is produce the final one, and that is what is final production ramp up is what they call it in the industry. But in our case, it's just a assembly of like the final design implementation. We are prototyping. Prototyping would have taken only parts of the robot and done the testing. So in this example, for example, we are only testing the throwing mechanism here, and we are prototyping. So that's the difference in prototyping. And the production or ramp up, I'm saying, is for the final assembly. That is when the real robot is done, basically. So yeah, that is it. How long have I taken? I was planning for, oh, like perfect. So 1 hour, 45 minutes. Good. So conclusions. I think I've stressed on the conclusions enough. All of you by now hopefully have gotten these points clearly understood, that there is a separation between concept generation and selection. We spent a lot of time talking about it. We spoke about how the scoring is done. All the critical evaluation while generating concepts should not happen during generation of concept. It should save it for the selection phase. No critical evaluation while generating, right? This will improve the chance of selecting concepts being the best one, right? We otherwise we'll directly eliminate something that actually would have been the winner later, right? If you did it more systematically. So yeah, that separation. Process flow is excellent for reasoning. If someone comes and tells you, asks you questions, we already discussed two kinds of questions, right? Why you chose this idea? Why is this a new idea that someone comes up with? That also will be considered. All of these different questions that people can come up with, you'll have good reasoning for all of the answers you'll have basically ready with you whenever someone comes and asks you, because you have followed this process systematically. And also it's a very good thing to have a template, right? When you start a project and you have a template already set out for you, you just have to follow it. Unlike you have to create a new template, that is more work. So this is a predefined template for you. You just have to follow these instructions and you'll have a project at the end of the day, hopefully, ideally. May not be as simple as that, but in practice, it is close enough. You have something to follow, basically. So that is the conclusion. That is all for this presentation. I think I can take questions now, or shall we share the quiz? Do I have anything left to say? Probably not. So I think if you ask questions, I can answer them, or we can go on to the quiz that is there. There are like 5 questions that kind of put out in a Google form. So just to see if you guys have understood everything, and for you yourself to see if you have understood what was discussed, you can. Okay, I hear some requests for summary. I could summarize it again, but let's see, wait for some more time before there are questions, maybe. If there are no questions, I'll do a summary again. And okay, I see quite a few, like 4 or 5 requests for summary, so I'll do that. Can you just summarize concept scoring in a few sentences? I missed it. Okay. Small summary on the concept selection and scoring. Okay. Cool. Anything else while I wait? So far, all the requests are for summary, so I'll summarize. But before I start summarizing, maybe any specific questions that I want to take? Okay, I guess I'll do the summary quickly and then we'll go on to the quiz. So to summarize, this is a flow: planning, concept development, detailed design, and prototyping. Well, you can also say production as a separate step. So planning, concept development, detailed design, prototyping, and production. So detailed design and prototyping, I treat it as a single step because this is a very tightly integrated thing. Like prototyping and detailed design is literally one thing almost. The loop is so tight that it becomes one, is how I visualize it at least. So detailed design and prototyping is one block, is how you should also visualize it in my opinion. Concept development is the step before that, and production is the step after that. So what is concept development? It is two things put together. One is concept selection and one is concept generation. Concept development is two things: concept generation and concept selection. Concept generation is a diverging part of the funnel, and concept selection is a converging part of the funnel. And that diagram was shown here on the right in the small picture. You can see concept generation is the first step where you diverge, and concept screening or selection is when you converge. What is diverge? You look at all the possible ideas on the planet and all the possible inside your own planet, inside your head. So, and your team's minds, basically. So, your generation is search externally for all the ideas that other people have come up with and search internally for all the ideas that you can come up with. And that is generation. And when you do generation, you are not critical. You simply do it free minded. This is artistic in nature almost. You should be very creative. You should not be critical. You should not bring out the engineer in you. Leave the engineer at home, come up with a artistic mind, little more free thinking mind, and generate concepts without any filters. All the filtration happens in the screening phase, which is exactly thinking out of the box, no constraints on yourself. So that is generation. Then you have to, now that you have a huge list of ideas, you'll have to select one winner or two winners or a few winners that you will actually use, right? Actually implement. And what are those? How do you decide? This is where you bring in your critical thinking, where you have a scoring. So how do you bring your critical thinking? This is the way to do it: a scoring system. A scoring system where you have a list of parameters. When you select, you want to decide how will you select, what is your parameter for deciding that this is the winner, this is not. So that is what the parameter and weight is. You have to kind of decide what are the things that matter and how much do they matter, are the parameters and weight. And then you will put all your concepts on one of the axes and start scoring everything based on the things that matter and how much they matter. You will start scoring. Then you'll just multiply the weight with the score and you will add up and you'll get a score for each of the ideas. Whatever score you get, you can decide the winner, top three, and then choose the top three and start doing detailed design. I think I don't need to summarize detailed design and prototyping because that's quite obvious what you have to do there. You do detailed design, prototyping, detailed design, prototyping. It's a loop. Once you have finished this loop of iterations, you know what your final design looks like. And that is where production and ramp up happens. Now you can build the actual final product, right? I hope the summary was kind of clear. I think that summarizes it all. Yes, in the chat, if it was clear, all the people who have asked for summary. Okay, cool. I can see a few yeses. Awesome. So that seems clear. Process flow. Did I miss out anything in the summary? Yeah, that was a summary. Motivation and all is what I've missed out, but I hope that was clear. Okay, so I think now that I am done, I can hand it over to the team. They have a few words to say about EY-IC, I think. Amit might want to present something, and then also there's a quiz. So Deepam or
Hi Arjun.
Gargi.
So what we have
Yeah,
done is we have already posted the quiz link. I'll repost it again. Just give me a second. And then Amit can speak, or he can speak about EYC while people attend the quiz as well, I think. Uh,
cool.
I think
Yeah,
better
that was
later on. So maybe what we can do is the quiz link is posted. 10 minutes is like 10 minutes given for the quiz to attempt.
cool.
We can give time and then Amit will brief everybody about the innovation challenge. See, I'm putting the quiz link again for anybody who missed it above.
Yeah. So that was Gargi, by the way, speaking through Deepa ma'am's speaker. So
Hello,
yeah,
everyone.
so yeah, so she has posted a form link, and I guess you can. There are just 5 questions, so you have 2 minutes for each question, which is way too much time. But yeah, it's exactly what we discussed. In fact, the questions that are there in the form are exactly what I've already asked in the live session. So you can open it up, and 10 minutes is more than enough time for answering those 5 questions. It's MCQ. Just tick, 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 and it'll be done. So yeah. I'm also still listening for doubts if you guys have any. Although if the doubt itself is the quiz question, then I might want to avoid that doubt. But
Okay, Arjun.
otherwise, yeah.
Yeah, there is one doubt. So, in the product development process that you mentioned, right? So, any point in time, we can go to previous one wherever we lack certain information, then we go back and come again to the phase. But could you share the tools that one can use at any point in time? Because you have been developing different products, let it be school or let it be your own robots control system. But then, because the students are from college and they might start the project in the initial first project. So, could you suggest certain tools that one can use at each phase of the development process?
I see. Okay, yeah, that makes sense. So, some tools are kind of obvious if you spend some time thinking about it, but I'll just explicitly say it now so you can be more focused on actually using those tools. So, should I share the screen and say it? But it's okay, I guess I can just say it orally. So in the detailed design phase, those tools are up to whatever project you have been working on, right? So in my case, I have been doing a lot of robotics and mechanical design stuff. So I use a lot of CAD tools. So those are specific to whatever product you're designing. But there's one tool that is, I guess, what might help a lot in this process is during the concept development and generation phase, excel sheets excel sheets are the best. You can use them uh, very effectively in all of these processes. They're very, very useful. So basically, all I'm trying to say is get used to using Excel. It's not just for when you get a job and you're supposed to do some boring things on Excel, but also for when you're doing fun projects. If you know to use Excel properly, you'll be surprised how useful they can be. So clearly, for example, scoring is that something has to be done in Excel sheets. You'll not take pen and paper or board, which is completely slow and ineffective, right? You'd rather put it in Excel, and you can be very descriptive with whatever concept you have come up with. If it is an external search, for example, you can put links to wherever you found those ideas. If it's an internal search, you can insert images into the Excel sheet itself. So when you have one look at the sheet, you know all the concepts in and out, right? So that is how I have used Excel sheet way too much for all of these things. So concept generation, you'll create an Excel sheet of all the concepts that you can create. Concept selection, you'll just use the concept generation, refer to the concept generation sheet, and map it into X and Y coordinates of the sheet, basically. Um, so yeah, uh, I guess Excel sheet is one of the most useful tools in this case. But yeah, apart from that, the tools for detailed design and all that is kind of, I guess, you will know when you're doing the project. It's too broad a question for that. So, yeah.
Hello everyone. You need to submit the quiz in the next 6 minutes because at 12:18 we will be shutting the quiz and you will get your certificates only if you qualify for the entire session. That is, you sit through the session and you submit the quiz within the stipulated time. And please stay till the end till we say that the session is done because we have an important EYIC announcement as well. Thank you.
Maybe you guys can also raise your hands once you have submitted the quiz. Although I guess the team might be seeing the results on their screen. Still, just to see it on WebEx itself. Once you're done, you can raise your hands maybe. Yeah.
We have unmuted all of you, so you all can unmute yourself and ask any doubt that you all may have.
Hello, ma'am.
Hi, Aryan. So,
Sir, the timing of this meeting cannot be after 2 o'clock because
isn't
my
uh,
college time is from 10 a.m. to 4:30 p.m. and my miss important lecture.
oh, like you're referring to the future technical sessions, right? Like this session is already over, so I mean, it's kind of late for that. But I guess you're referring for future sessions if it can be scheduled for evenings. And is that your question? I guess, does someone want to take that question?
Excuse me, sir.
Yeah.
My submit button is not working. I'm trying to submit it, but it's not working actually.
Oh, could you probably refresh or open the form again in a different tab, maybe? I hope it is not too much. I think Google Forms, by the way, will remember your data, so it'll autofill it, I guess, if you refresh as well. So you can try refreshing and submit.
Okay, let me try.
Yeah. For Aryan's question about the schedule, not sure what to say right now. All the rest of the sessions might have been scheduled, or maybe someone from the team can answer that question if they have an answer for the timing of the sessions.
Okay, sir.
Yeah.
Excuse me, sir.
Yeah.
Sir, today, right now, we have exam. Can you schedule this meeting later?
Oh, but this meeting that was it. Like the main concept and like the main topic is over. Now we have a few closing things to be done, which will only take like probably 10-15 minutes at max, and then we can wrap. I think quiz time is also almost up. I think most of you guys must have started submitting and finished with submission. So in which case Amit can do the last part of the session and then we can wrap it. That is also.
Sir, I have one doubt.
Just 1 second, Arjun. So we'll be shutting the quiz in another couple of minutes. So and ask everybody to wait back even after the Q&A. We have a few important announcements.
Yeah. Okay, last like 1-2 minutes left, I think. So quickly, I guess you guys should submit your quizzes and obviously stay back, as Gargi has repeatedly mentioned. There is one important announcement left to be done, but we want the quiz to be over before we start with that. So,
Sir, I have a doubt.
yeah.
So you talked about generating all the possible concepts in this universe and then concepts in our own mind, right?
Uh-huh.
and then we have to select one of the concept which is very much friendly to us, and then we have to keep in mind the users or the consumers perspective also.
Right. That is why you decide the weightage for all your parameters. Yeah.
Okay, so can you just tell me that the one generalized factor which we have to keep in our mind while keeping this in mind, while keeping the consumer's perspective in mind?
So that, I think that I was talking about basically parameters. So in your concept scoring, you have your list of ideas on the x-axis or whatever. On the y, you have a list of parameters and a weightage, right? So the list of parameters and the weight, how do you decide what are the parameters and what are the weights for each of these parameters? There are two ways to go about it. In my projects, I have been doing it the kind of inferior way of doing it, which is the like second best thing or next to best thing, which is to decide it by yourself. You know what the important parameters are and you know what the weightage should be, so you directly fill it up yourself. But what I was saying is, in industry, that's not how it works. In a professional setting, that's not how it works. You're supposed to do a proper survey to figure out if you're designing for a customer. That is the key point here. If you're designing for a customer, then you have to think about what the customer's parameters list and scoring should be. That's all. But that list you can decide for yourself if you're designing just for your team, and if it is a BTech project or if it's an MTP or something like that. So that is all. So
Okay, okay. Thank you so much.
yeah, sure.
Okay, yeah, in the
Uh,
interest of time, I'll have to start now because I have also some. We have certain deadlines because everyone has to go as well, right? So, thank you, Arjun, for the amazing session. We can circle back to the questions again. Maybe you can put it in the chat and then we can answer them in the next 10-15 minutes. So, before I begin, let me tell you that at the end of what I'm going to present, you can get a 10% discount flat. Okay, so in order to get that 10% discount, you'll have to wait. So please make sure that you listen till the end. Okay, so let me start. I'll take just 10 minutes and brief you what the innovation challenge is all about. Okay, great. So what we are going to talk about is the eYantra Innovation Challenge. The registrations for this challenge are currently going on. Okay, so if you're not aware of what this challenge is, or if you have not registered, please stay back because it's going to help you a lot. I'll play a short video to tell you what EYIC is, and then maybe it's a 1-minute video, and then I can get into the details. Just let me start sharing again. 1 second. I think you did not get the sound.
The eYantra Innovation Challenge is a competition that trains students in innovation and entrepreneurship. It nurtures young minds to articulate real problems in society and to solve them using technology. It immerses participants in problem domains and articulate problems which then they solve and use the solutions as a basis for startups. It's a platform to showcase solutions to incubators and to build your dream startup. Guidance is by eYantra engineers and industry experts. So join us. Registrations begin on the 1st of September every year. Join us to solve real problems using technology and to engineer a better world for all of us tomorrow.
Okay, so I hope you got what Innovation Challenge is. And this year, which is the 9th year of the Innovation Challenge, we have collaborated with a lot of partners, which includes Deutsche Bank, Sign, IIT Roorkee, of course, IIT Bombay, Sign, which is the official incubator at IIT Bombay, then IIT Tirupati, GIC Hub, this ISAT school again at IIT Bombay, CEPT University. design bridge foundation, and idea. So all these things maybe some of these things may be new for you. So let me go into the details about these things. It will take 10 minutes more. Yes, so we have two themes in this competition. First is sustainable and advanced technologies for helping urban inclusivity, and the next is agriculture. Now, in this competition, even if you're not aware of what these themes entail, you don't have to worry about. And you can come with a very clear mindset. If you want to build your own startup, if you want funding for all those things, and if you want to learn things
Hello.
like
Hello.
things like which we taught in the session today. Can you please mute everyone? Uh, yeah, thank you. The participants as well, I think. Okay, thank you. Okay, great. So moving on, yeah, these are the two themes that we have. And even if you're not aware of what these themes are, we are going to detail out the things that you require to help solve problems in the theme. Okay, so I'll proceed with. Yes, what sustainable and advanced technologies are helping urban inclusivity is. So there are two different categories, and your solution for in this theme can be assistive technology or universal design. And the tools that you're using that we would be training you in would be the GISE, which is the Geographic Information System, Internet of Things, IoT, product design and service design, which you just saw trailer of that in Arjun's presentation, and robotics and automation. So there would be certain training involved in this competition first. And to give you more details, maybe I should jump to the schedule now. So in the first sprint, what you're going to do is you're going to learn about first what the theme is, and next about innovation and entrepreneurship, certain things which Arjun has already talked about, but we'll dive into more details in it. And at the end of it, you will submit a proposal for the problem that you want to solve. And if you don't have a proposal, then you don't have to worry about, because we will be giving you a set of problem statements as well. So you have two options: either you submit your own problem and a proposal, or you can go ahead and just select from one of the problem statements that we have given. Okay, and you would be having expert live sessions from the partners that I just talked about in the beginning. Okay, the next is the prototyping sprint, in which again you will get some MOOCs on Internet of Things and Geographic Information System, which is GIC, and you will develop a proof of concept for the proposal that you had given us in the previous sprint. Okay, after that, we move on to the innovation sprint, in which you are going to learn go-to-market concepts again with the help of MOOCs from our industry experts. And there would be certain guidance from the official incubator as well as DIC to help you develop a pitch. So pitch is something in which you tell the incubator that this is my product, this is what I'm trying to solve, this is the market value that it has, and this is why it's necessary to solve it. So these are the certain things which you cover in a pitch. It's a 5-minute PPT, you could say, in which you try to cover all these things. And the final sprint is the implementation sprint, in which you cover all the concepts that you have learned till now in the previous 3 sprints. And then you submit a final pitch deck as well as a technical demonstration of the idea that you are solving. The technical could be hardware, software, whatever it is, depends on the problem that you are trying to address. Okay, so what is the participation criteria this time? So this time it is open to all, in the sense that from any stream, any department, and even different colleges. So we have multidisciplinary teams also possible. You can have maximum of 4 members and minimum of 2 members, and additional 1 guiding faculty for the entire team, which can be from any college that you want. So it could be undergraduate, postgraduate, PhD level, it doesn't matter. You can form multidisciplinary teams from different colleges as well. And there will be a leader for the team, which would be the single point of contact who would be dealing for the entire team with us. Okay, so that is all about the schedule, and these are the benefits that you'll get. We have a total pool of 1 crore seed funding for the startups, which will include even your funding the startup for 1 year after you proceed to the finals. For the finalists, we are ready to give stipends for that as well. So this 1 crore would be given from our partners, and of course, this will depend on the finalist and how their final output is. The second thing is 25 lakhs of prizes. These are cash prizes and goodies which you will get if you reach a certain level in the competition, of course. And finally, you will build skills in IoT, GIC, product design, and robotics. So these are 4 different categories in which you are going to develop skills throughout the 6-7 days term. Yes, so the registrations are already going on. You can visit our website. I'll put it in the chat as well. And once you go there, you will find all the details that I have mentioned. At the same time, the registrations end on 25th September. So please don't forget that. And Yes, this is the referral code that I was talking about. So you can get a flat 10% discount on the price which is mentioned on the website, which is 2,500 per team. So that comes down to around 500 per person if you have a team of 4. And you can get additional 10% off if you use the following code. So that's it for EYIC. I'll pass the floor back to the team, and they have some interesting polls for you, which you can answer. Thank you.
Okay, Amit, yeah, done, right?
Yes, please.
Okay, cool. Thank you, Amit, for sharing about the innovation challenge. So, Amit, could you post on chat the details like EYIC website and the deadlines and so on?
Sure. I'm just doing that.
Okay. Yeah, thank you so much for a brief introduction to the e-Yantra Innovation Challenge that you have done. And we thank you, our speaker, Arjun, for sharing wonderful presentation on product development process. So thank you, Arjun, for that. And any queries, any doubts you have, you can post it on support@e-yantra.org also to us. We'll be we'll be happy to interact with you through email also. And yes, so now there is a poll that we would like to take. So please don't leave the meeting now. We would like to take a poll from you all. This is a general poll that we wanted to know from you